For nearly half a century, NASA's Explorer 1 spacecraft, the furthest-reaching shuttle ever launched, continues its breathtaking journey throughout the cosmos. By returning crucial information from the furthest regions of the cosmos, Explorer 1 has contributed to our overall understanding of the universe. The space world is in a state of shock and confusion as a result of confusing signals that have been revealed in recent transmissions from this incredible rocket. Debatable among these indications are whether they are the result of a technological glitch or if they point to something much more remarkable, like extraterrestrial activity. Come along as we explore the enigma underlying these remarkable signals and discover what might be lurking deep within space. Since the beginning of space travel, humankind's curiosity about the mysteries that lie beyond our planet has been its main motivation. This insatiable curiosity led to the launch of some of the most ambitious space missions ever, including Voyager 2 and Explorer 1. A new era in space exploration began on August 21, 1977, with the launch of Voyager 2 from NASA's Kennedy Space Center. September 5th, only 14 days later, Voyager 1 arrived, paving the way for a remarkable voyage. The launch of these twin spacecraft, which weighed about 720 kilograms apiece, about the size of a small car, coincided with an unusual alignment of the outer planets, which was essential to their trajectories and mission outcomes. These shuttles went at different speeds and in different directions during their incredible journey. A turning point was reached on December 15, 1977, when Voyager 1 passed its twin because of routes that differed. Since then, Voyager 1 has become an indispensable tool, yielding important data that has fundamentally changed our comprehension of the cosmos and all of its quirks. Prior to delving into the most recent incredible finding that has the space world buzzing, let's take a moment to reflect on some of Voyager 1's greatest successes. When Voyager 1 launched its Jovian imaging mission in 1978, it was located roughly 265 million kilometers from Earth. It started an amazing 100-hour mission in January 1979 and produced an amazing time-lapse movie of Jupiter's rotation. Impressive views of Jupiter's intricate features and dynamic atmosphere were provided by this 3,750-image series. The spacecraft found 2 previously undiscovered moons and a tiny ring surrounding Jupiter, which significantly increased our understanding of the complex system surrounding the gas giant. Corrective actions were carried out to guarantee the spacecraft's safe passage and prevent any potential interactions with Titan, one of Saturn's moons. Following the triumphant Saturn mission, researchers made the decision to terminate the planetary missions of Voyager 1 and Voyager 2. The spaceship, however, was rerouted on a new course that sent them outside the solar system and beyond it at an incredible 325 million kilometers per year. The interstellar mission started in January 1990, and Voyager 1 kept on with its celestial voyage. Voyager 1 made a number of important discoveries during this time, including the identification of 4 more moons, Rhea, Tethys, Enceladus, and Mimas. It also took some of the most famous pictures in our solar system. On February 14, 1990, Voyager 1, which was almost 6 billion kilometers from the Sun, set out on a photographic expedition that came to be known as the Family Portrait, producing breathtaking pictures of the solar system's planets. This set of 60 images augmented the remarkable set of 670 photos that Voyager 1 took during its rendezvous with Neptune. During its voyage, Voyager 2 also accomplished some incredible firsts. As it got closer to Neptune, it measured wind speeds that were above 13,100 meters per second, the fastest winds that have ever been measured in our solar system. With its surface temperature plummeting to a bone-chilling minus 391 degrees Fahrenheit, Triton is one of the coldest places in our solar system. This accomplishment shed light on Neptune's far-off atmosphere. Unusual features of Triton included ice volcanoes that threw frozen particles 5 kilometers into its dense atmosphere and released nitrogen gas. Our comprehension of the varied and intricate characteristics of celestial objects situated in the most remote areas of our solar system has been broadened by these astounding revelations. Results from the Voyager missions have been revolutionary. The moons of Jupiter and Saturn, which were previously believed to be severely damaged and inert, are actually teeming with geological activity, according to Voyager 1 and Voyager 2 data. Particularly Voyager 2 accomplished a number of noteworthy firsts, such as being the first spacecraft to pass by both Neptune and Uranus. In order to prolong the operational life of these ambitious spacecraft, NASA implemented a number of techniques, such as turning off non-essential equipment and radiators to save energy. It is anticipated that the mission will come to a conclusion in 2030, providing the scientists and engineers who have dedicated their lives to this remarkable project with a moment of pride and a hint of sadness. An engineering marvel, Voyager 1 and Voyager 2 were designed. The purpose of these spaceships was to serve as steady platforms that rotated at a speed that was over 10 times slower than the hour hand on a clock. This design decision lessened visual fuzziness, while the spacecraft traveled across the enormous void of space. The spacecraft started sending back photographs of Jupiter even before it reached the outer planets. These images showed the planet's whirling clouds and well-known features, like the Great Red Spot, a huge storm that captivated viewers at NASA's Jet Propulsion Laboratory. But the biggest news came from the finding of active volcanoes on Jupiter's moon Io. Unusual signals from Io were picked up by the spacecraft's instruments, and these signals were verified by in-depth photos that revealed a surface scarred by eruptions and tall volcanic plumes. With an eruption 100 times stronger than Mount St. Helens, one of Io's most well-known volcanoes covered an area almost the size of France. Eventually, the cameras were shut off to save power and memory before the spacecraft entered interstellar space and resumed its voyage. Interestingly, for a variety of reasons, neither Mercury nor Mars was visible in the pictures they took. In addition to the Voyager missions, NASA has launched several more noteworthy spacecraft, such as New Horizons, Voyager 10, and Voyager 11. Voyager 10 overtook Voyager 11 to become the spaceship that was furthest from Earth on February 17, 1998. Voyager 1 continued its single mission for 14 more years before entering interstellar space on August 25, 2012, even though there were no other space probes to monitor it. The Voyager missions were successful because of a number of creative techniques, the most notable of which being the use of gravity assist maneuvers. These actions were essential for getting the spacecraft to its far-off destinations and collecting vital data. In order to accomplish their objectives, the spacecraft needed assistance from gravity in addition to their own propulsion engines. Imagine the two courageous rockets moving across our solar system at a smooth pace, driven ahead by the planet's gravitational pull. They were able to save fuel and reach the required speeds to visit several destinations thanks to this celestial dance. During extremely precise orbits, the spacecraft is given a tiny portion of a planet's energy in order to assist with gravity assist procedures. For instance, Voyager 1's speed increased as it got closer to Jupiter due to the planet's strong gravitational pull. Reaching this level of precision was essential because even a small departure from the proper angle or speed may have had fatal consequences. The amazing minds behind these missions accomplished these gravity assistance on multiple occasions with remarkable precision, enabling the spacecraft to go on an incredible journey. During the amazing journey made possible by these gravity assist operations, Voyager 2 reached Uranus and Neptune by utilizing gravity aids from Jupiter and Saturn. These gravity assists have played a major role in the Voyager mission's success. We eagerly anticipate more details on the examination of the new anomalies on Voyager 1, as we consider the amazing trip of these exploring spacecraft and the abundance of data they have contributed. Beyond the bounds of our solar system, Voyager 1 and Voyager 2 continue their journeys, reaching planets such as Neptune, Jupiter and its moons, Saturn and its moons, and Uranus. Time-lapse images taken by Voyager 1 clearly show 10 rotations of Jupiter, including the discovery of new moons and a tiny ring. These findings have substantially improved our comprehension of Jupiter's intricate system, along with finding 4 more moons, Mimas, Enceladus, Tethys, and Rhea. Voyager 1 also captured amazing images of Saturn and its rings, which shed light on the planet's complex system. By traveling to Uranus and Neptune and providing insightful information on their moons and atmospheres, the spacecraft created history and advanced our knowledge of the furthest reaches of our solar system. Voyager 1 and Voyager 2 left their planetary missions behind to explore interstellar space and collect data on the enormous environment. The results of this continuous research continue to broaden our understanding of the universe outside of our solar system. Scientists and space fans alike continue to be intrigued and inspired by Voyager 1's incredible voyage, even as we wait for additional details regarding the spacecraft's most recent signals and their potential implications for our understanding of the cosmos. Their outstanding accomplishments demonstrate the enormous promise of space exploration, while also pushing the limits of human knowledge and exploration. We have access to a wealth of information about our solar system and beyond thanks to the Voyager probes. In addition to the amazing pictures and data, the spaceship also carried a unique artifact, a golden record meant to tell the tale of our planet to alien visitors. The sounds and pictures on this album are meant to capture the variety of life and cultures that exist on Earth. It has greetings in 55 languages, music from other civilizations, and a variety of ambient noises, like whale songs and thunder. In a sense, this message in a bottle expresses the hope that, should intelligent life exist elsewhere, they would eventually discover and comprehend it, providing a window into the core of mankind. Scientific tools that were carried by explorers 1 and 2 have revolutionized human knowledge. Among these instruments was a magnet, ometers, imaging systems, astronomical ray instruments, and plasma wave detectors, all of which provide vital information about space events. The magnetometers have yielded valuable insights into the magnetic fields of Jupiter, Saturn, Uranus, and Neptune. These insights have shed light on the intricate interactions that exist between these planets and their environs. Our understanding of the solar wind's characteristics and how it interacts with planetary atmospheres and magnetospheres has improved because of the use of plasma wave detectors. The capacity of the Voyager missions to measure the heliosphere boundary, a vast bubble of solar particles and magnetic fields enclosing our solar system, is among their most important contributions. Voyager 1 saw the abrupt change from the solar wind to the interstellar medium as it got closer to the border of this boundary. Our knowledge of the heliosphere's structure and function in shielding Earth from cosmic radiation has greatly benefited from these facts. The termination shock, which is the point where the solar wind slows down and becomes denser, has been identified by the spacecraft's findings. The heliosheath, which is located beyond this point, is an area where the solar wind and interstellar medium mix to create a dynamic and complex environment. The voyage of Voyager 2 has been equally important. Its successful flybys of Jupiter, Saturn, Uranus, and Neptune have not stopped it from giving important information about our solar system's outer regions. The peculiar magnetic field of Uranus, which is dramatically skewed with respect to the planet's rotation axis, was made evident by Voyager 2's observations of the planet. This finding called into question accepted theories of planetary magnetism and encouraged additional research into the magnetic properties of other celestial bodies. Apart from their scientific input, the Voyager missions have significantly influenced the general public's curiosity about space exploration. The world has been captivated by the breathtaking pictures of far-off planets and their moons, as well as the intimate accounts of the spacecraft's voyage. Numerous people have been inspired by pictures of Saturn's rings and the in-depth views of Jupiter's moons, especially Io's volcanic activity, which have also been featured in instructional materials, documentaries, and popular media. These missions have emphasized the value of exploration and the pursuit of knowledge, fostering awe and curiosity about the cosmos. Not to be overlooked are the engineering and logistical feats that the Voyager missions performed. The spacecraft were built to withstand harsh environments with temperatures as low as -220 degrees Celsius while they were far from Earth. Despite being far from the Sun, they were able to rely on a dependable energy source because to radioisotope thermoelectric generators, RTGs. Among the many difficulties the engineers had to overcome in order to develop and construct these spacecraft were making sure that the instruments would last for many years and that communication would be possible across such great distances. Our comprehension of the larger cosmic environment has also been impacted by the information the explorers brought back. The spacecraft have contributed to the mapping of cosmic ray dispersion and have revealed details about the composition and density of interstellar dust. This data is essential for planning future missions that may investigate other star systems, as well as for comprehending the conditions in the interstellar medium. In addition to the information previously revealed, the explorers' legacy is cemented by the inspiration they provide for future discovery as they continue their trip into interstellar space. The missions have established a standard for large-scale, long-duration space missions and have cleared the path for novel technology and methods in space science. They serve as examples of the potential for human creativity and the importance of tenacity in the face of overwhelming obstacles. Future spacecraft and mission concepts have been influenced by the Voyager missions. With the aim of reaching farther into space, future missions are being planned to build on the achievements of the Voyager program. These next missions will build upon the groundwork established by the Voyager spacecraft while continuing to push the envelope of human understanding. To sum up, one of the greatest accomplishments of humans in space exploration is the Voyager missions. Their effects on public imagination, scientific discoveries, and significance in expanding our knowledge of the solar system and beyond emphasize the value of ongoing inquiry and curiosity. Voyager 1 and Voyager 2 continue to represent human ambition and the never-ending pursuit of knowledge as they venture farther into the cosmos.